Alrighty, so we are going over we are reviewing some concepts. We are going over some important concepts ahead of the last assessment. We are hammering home the final ideas before the final assessment, before the final part of the calendar year. Yeah, let's just keep it going. So, when it comes to writing three valid congruency statements given the triangles below, basically what they're saying is what they're asking for is and can you I mean I guess is there can you write three congruency statements that are relatively different from one another that still reflect the reality of um, of these two triangles. So just starting going with the reference angles, just going with the reference angles 1, 2, 3, triangle PTW is congruent to triangle, and then reference angle 1, 2, 3, HGD. Excuse me. So that would be one. That would definitely be one congruence. One congruency. Then another one would be if I started at reference angle 2 and then just went 2, 1, 3. So reference angle 2, 1, 3. So triangle TPW is congruent to GHD. And then finally, I'll go with WPT congruent to 3, 1, 2, yeah, DHG. So again, as long as, so again, this kind of illustrates the importance of reference angles and reference sides and reference points. Wherever P appears in these congruent statements, H appears next. So we've got P in the second index, H in the second index. Wherever W appears, D appears. W, D, W, D. And so it's, yeah, I mean, yeah, that's how important these reference angles are for these congruency statements. There are a bunch of different varieties on how you can write them. But yeah, that's basically three valid congruency statements given them. So um, let's see, given the congruency statements, list all congruent sides and angles. So just like above, I've got angle A is going to be congruent to angle M. Angle B is going to be congruent to angle N. And angle E is going to be congruent to angle P. And again, just like I meant, oh, here we go. I'll even get it in frame for you. And just like I mentioned with the similarity tests, understanding this in principle is perfectly fine. But putting it in practice, like with some of the problems we're going to be doing later, that's kind of where a lot of folks fell off. So filling in these relationships, I'm not too worried about those as far as the class is concerned. But actually using these congruency statements, actually using these statements to get information in order to solve a problem, that's kind of where we need work, and that's kind of why we're doing these extra worksheets and these extra problems. So for the sides, I've got side AB is congruent to side MN. And notice how I don't even have a drawing, and I'm using the congruency statements in order to construct the sides that I know are related to each other. So I've got side BE, so that's going from point B to E, and that's going to be related to NP because again, where B is, N is, and where E is, P is. So NP, and by the same token, P, so by the same token, EA is to PM. So based on the congruent statements, you should be able to just read what angles are related to one another. You should know what sides are related to one another. Yeah, and so, yeah, let's start with and write another congruency statement. It's the same, you have the same 3 points, but you're basically just writing them in a different order. So I'm just going to go backwards from what we had. EBA is congruent to triangle PNM. And this one still works because wherever and looking at the original congruent statement, let me make sure we can still see that. Let me hang on a second. I'm going to zoom in with the camera a little bit. I took a little bit of a break, so zoomed in a little bit too much there. All right, there we are. Took a little bit of a break and I had to reset the camera. So, all right. So looking at this, so there we are. So looking at this congruency statement, wherever A is, M is. And that also continues with this new congruency statement. Wherever A is, M is. Wherever B is, N is. So B and then N. And so the order of the points isn't really as important as much as it is the fact that they're still connected to each other in relative congruence. And you'll notice also BA is still related to NM as it is up here. BE is still related to NP as it is up here. So the relationships are still exactly the same. I mean, the order may be a little bit around, but the points referring to the line segments are still exactly the same. So that's how powerful, as far as the information goes, that's how powerful these congruency statements are for telling you about these two different triangles. So we'll keep going with this. So QRY is congruent to JLS, so angle Q is congruent to angle J. J's look like T's for some reason. Angle R is congruent to angle L. Angle Y congruent to angle S. Alrighty. Now for the sides again, I'm just going to pick 2 points, and as long as the 2 points reference the same 2 points on the other triangle, I know immediately that the sides are going to match up with each other. So side QR is going to be congruent with side JL. Side RY is going to be congruent with side LS. And finally, side YQ, I don't know why I said G, YQ is going to be congruent with SJ. And then write another valid congruency statement again. The order isn't necessarily as important as the fact is that Q matches with J, R matches with L, and Y matches with S. So I'm going to go with RYQ is congruent with triangle LSJ. So that would be another valid congruency statement. All right. So with this next set of problems, spanning the whole worksheet, so hopefully I'm zoomed in enough you can actually read some of them. If not, I mean, the worksheet's on Canvas. Given STU is congruent to KLM. All right, so here we go. Let's see, I'm going to zoom in a little bit more here. There we go. There we go. All right. So given that STU is congruent to KLM, complete each of the following statements. Now, even though they aren't asking for measurements, even though they're asking for, in this case, they're asking for sides. They're not asking for measurements. They're not asking for angles. They're asking for sides that these are related to. If you are given a picture with a congruency statement, always, always, always start by mapping the reference angles with the congruency statement. So I've got S is related to K. I've got T related to L. And then I've got U related to M. Do you see how messed up and rotated these ones are? Just based on, I was going to say, just based on their relative position, it would not be unreasonable to say that TU is related to KM or LK is related to SU. Um, even if even if you just did a cursory glance of the of the excuse me of the wow, even if you just did a cursory glance of the congruency statement, there we go. Some people get really hyped and energetic after they eat. I apparently lose all brain function. Um, even if you do, even if they just do a cursory glance with that, having the reference angles, it is a way of eliminating it is a way of just eliminating error, and it's also it's a way of eliminating error. It's good policy, it's good practice, and I still just it's just the best thing. It's just the best thing to do under these circumstances. If you're given a similarity statement or a congruency statement, take the time to map out the reference angles, because then you know you'll be 100% right. Because TU, for example, is between reference angles 2 and 3. What else is between reference angles 2 and 3? LM. And I know that's the 100% correct answer. KM is between reference angles 1 and 3. So is SU. LK, reference angles 1 and 2, same as ST. So angle M is reference angle 3, and on this triangle, U is reference angle 3. Angle T is reference angle 2 on this triangle. Over here, that's angle L. Oops, I'll deal with my... So I've got angle UST, so that's reference angle 1, and that's also that's going to be equivalent to reference angle 1 on this triangle is going to be, well, since they're using the 3-letter phrase, UST is going 3, 1, 2, so it would be MKL. All right, triangle UST is also going 3, 1, 2, so it would be MKL. Then triangle TUS is going reference angle 2 to 3 to 1, so that's LMK. So there we go. Could you have done all of those just looking at the similarity statements? It is entirely possible. Yes. Um, it is entirely possible. Yes. Um, honestly, if I had gotten the congruency statement and I would have been asked all those different questions, I would have just drawn the 2 triangles, and I would have said, the heck with it, drawn the 2 triangles, get the reference angles, drawn the 3 points, and done it that way. If you're just going to be asked questions of this level of simplicity up here, then you can just go with the congruency statements, and you'll probably be in with just the congruency statements, you'll probably be in good shape. But as soon as you start getting into more complex things where you have to find equivalencies and you have to say, what sides are equal to what sides, or you get these 3-point angle references, or these different triangle references where it's the same triangle but the points are in a different order, it's just worth it to draw the picture and then, of course, use the reference angles to track the same naming convention that the test is using. So again, here we go. We are working with, so here we are, we're working with number 5. Given that BCM is it's congruent to ZYR. Okay, so find each missing measure. All right, so this is given, so I've got numbers here, so that means I've got to do numbers here. But before I do anything, before I search for anything, I am going to map out my reference angles. That gives me B gives to Z, so that's 1. C is to Y. Okay, I probably could have guessed that one, but still, it's always good to be it's still always good to be 100%. And then M is going to be with R. Okay, all my reference angles are set. So let's see. I've got CM, which is between reference angle 2 and 3. On the other triangle, between reference angle 2 and 3 is 11, so CM equals 11 meters. All right, BM is between reference angle 1 and 3 here. So on the other one, reference angle 1 and 3 here is 15 meters. Usually I have to eat a lot of Taco Bell to have a long BM like that. Little joke for any gastroenterologist parents out there. Let's see. So I've got YZ. That is between reference angles 1 and 2 on this triangle. Between reference angles 1 and 2 on this triangle, however, it is 8 meters. All right. Now that we've got all the sides taken care of, now we have to take care of the angles. They're unitless and dimensionless, so we don't really have to worry about carrying over the units. But let's see, measure of angle B. Measure of angle B is just reference angle 1, which is 45 degrees. So there we go, it's 45. Measure of angle M, that's reference angle 3. Okay. Well, measure of angle M is 45. Well, the thing is, I don't actually have anything that I can really do with this. Oops. All right. So what I have here, I've got 103, and I've got 45 because again, 45 is the reference angle 1 here, leads to being equivalent over here with 45. But what I can do is I can solve for reference angle 3 here because I don't know it on this triangle either. But once I do know it on this triangle, then I know it. Once I know it on this triangle here, then I know it on this triangle over here also. So 180 minus 103 minus 45 is 32. So angle M is 32. And yeah, that's on camera. All right, sweet. And then finally, angle Y. Angle Y is reference angle 2. Well, it's also the only obtuse angle on our triangle, which is congruent to the only obtuse angle on our other triangle, which is 103. Not a great mystery, but still, it's always good to have the reference angles picked up just in case. So yeah, there we go. Yeah, we're in pretty good shape. We're just going through it. All right. For the last one on this page, then no, we don't have back on this one. We do have a wait. Do we have a second page? Yeah. Well, I'll be. Yeah. Oh, there is. All right. Sorry, I got distracted there. All right. All right. So for the last one, I got to adjust the camera between pages. I'll just let editing Richard fix that. So given ACP is congruent to LNX, find each. You know what? I'll let editing Richard take care of this now. There we go. All right, thanks, buddy. And of course, it's editing Mr. Foster to everyone else. But anyway, so given ACP is congruent to LNX, find each missing measure. So again, we have numbers, so we're going to have to actually write in numbers for these problems. So let's see. First things first, I've got to map out all of my relevant angles. So angle A is going to map to angle L. Angle C is going to map to angle N. And then angle P is going to map to angle X. And again, even though they're both the only obtuse angles on the triangle, you still write it down. If we still have to include a shared side with our proof statements, then we have to include an obtuse angle with our reference angles. So let's see, I've got XL. So I've got XL, which is between reference angles 1 and 3. Well, between reference angles 1 and 3 over here is 13 centimeters. So that means XL is 13. But here's the thing. I can I can fill in a bunch of other information before I'm even asked it. And how do I know I can do that? Because, and you know what? I'm going to do that. I'm just going to do that, and then I'm going to do this last. But I want to show you exactly how much information I can fill in just based on the congruent triangles and what we know about triangles in general. So I know that I know that this is going to be 21, and I know that these angles are going to be I know that these two angles are equal to each other because this is an isosceles triangle, which means that these two angles are going to be equal to each other. So this is going to be 29. That means that this is 29. That means that this is 29. And so that means that reference angle 3 for both of these is going to be 180 minus 29 minus 29, which is going to be 122 for both of them. I also know that between reference angles 1 and 2 is going to be 21 centimeters. And between reference angles 1 and 2, this one's also going to be 21 centimeters. But this is going to be 13, but this is also going to be 13 centimeters. Each of the sides is also going to be 13 centimeters. So there you go. Just based on the fact that I knew that that everything was congruent, and based on the fact that I knew the two triangles were congruent and that one of them was an isosceles triangle, I was able to fill in all of that different information just based on that information. So let's see what they're going to ask me for. AC, that's going to be 21 centimeters. PC, that's going to be 13 centimeters. Measure of angle L, that's going to be 29 degrees. Measure of angle C, also 29 degrees. Measure of angle X, 122 degrees. So again, once you reach a certain point, you're going to reach a certain point where a lot of the information you're going to run into, a lot of the information you're going to run into, it's not going to be repeat information, but you're going to see a situation, or you're going to see a problem, or you're going to see something on the assessment, and you're going to say, hey, wait a minute, isn't this, it's, I know that this is supposed to be the case, but isn't this the case as well? Or isn't this the case? Or isn't this? And you're going to have a bunch of information about the same problem. That is a good place to be in, because that means that you actually understand and remember all those extra details, and you can use them effectively. So this was a lot of information to just dump out all at once, but like I said, you have two congruent triangles. So every side is equal, every angle is equal. One of the triangles is isosceles. So all you need to do is know one of the sides, one of the angles, and you're done. That's all you need to know for both of the triangles as demonstrated here. Let's do another one, mostly because I'm feeling good about how that last one went, but also because there's another page. All right, well, this one's not as entertaining, but we'll still work with it. Given that XPS is congruent with DNF, find the values of X and Y. All right, so once again, we have a congruency statement, so we are going to map out our reference angles first. So X goes to D, P goes to N, and then S goes to F. Yeah, these are all kind of weirdly rotated and messed up, but anyway, because I've got the reference angles mapped out, now I can set up my equalities to solve for X and Y really easily. Start with X. X is 17x plus 3, and I'm going to set that equal to whatever value I find between reference angles 1 and 3. That looks like it's 54. Well, what do you know? So 17x is going to equal 51 divided by 17. So x is going to equal 3. There's the first one done. I am not even going to get into the statistics about how rare and unlikely it would be for you to guess which one would be right if you just eyeballed it. So really use the reference angles when you're doing these. All right. So for 4y minus 3, so that's 4y minus 3 equals 4y minus 3 is between reference angles 1 and 2. So between reference angles 1 and 2 is the value 57. So moving everything around, that gives me 4y equals 60, y equals 15. That's just from years of doing math. 4y equals y 60 divided by 4 is 15. So yeah, there you go. And it all started because I did the reference angles first. For those of you that do the reference angles first, way to go. For those of you that are watching this that aren't doing the reference angles, I have no words. All right, so given that triangle MTW is congruent to triangle BGK, find the values of x and y, all right? So MTW BGK, so we'll start out, M goes to B, there we go. Thought M went to G for a second. I'm like, well, I've seen weird things before, but all right, T goes to G, and then W goes to K. All righty. So got to solve for x and y. So where's my x? So, all right, 4x minus 3 is at reference angle 2. Also at reference angle 2 is the value 45. All right, so 4x minus 3 equals 45. All right, 4x equals 48. X equals 12. So you see how fast it is when you have the reference angle set up correctly? So for the next one, 11y plus 6 equals, that's at reference angle 1. Now, admittedly, this does present a bit of a problem because I don't have a value for reference angle 1. However, I do know what x is, and I do have 41 right here. So what I can do is I can feed x back into this equation here. So 4 times 12 is 48 minus 3, which is 45, plus 41 equals 86. All right, 180 minus 86 equals 94. So M is going to equal 94. And if M equals 94, that corresponds with angle B. That also has to equal 94. So 11y plus 6 has to equal 94. So 94 minus 6, please be yes. 11y equals 88. Y equals 8. Took a little bit of extra work, but still worked out pretty well. All right. Next, we have given PRS is congruent to CFH, find the values of X, Y, and Z. Oh, all right. We're kind of moving things up here. So I'm going to mess with the lights a little bit here. Yeah, I guess I'm doing that too now. I'm afraid editor Richard is going to have a really rough time with this particular video, but that's what he's paid for, right? All right, so I've got given PRS is congruent to triangle CFH. So what that means is, actually, let's see what this does. Here we go. I'm just trying to make sure that the lighting isn't too bad. All right, is equal to CRH. So the first thing we're going to do is we are going to map out the we're going to map out the reference angles. So P goes to C, so I've got P, and I've got C, and I've got R goes to F, then S goes to H. All right, now I have to find the values of X, Y, and Z. All right, well, let's see. Well, X is between, on this one, between reference angles 1 and 3, and between reference angles 1 and 3 here is 39. So 2x minus 7 equals 39. So 2x equals 39 plus 8. Two x equals 47. No, it's 30. 2x plus 7. No. No idea what I was thinking. Equals 39 plus 7. Why did I think 39 plus 8? All right, that's 46. X equals 23. All right. So x equals 23. We're in good shape. I have no idea why I saw that and read 38. Anyway, let's move on to y. So with this one, 13y minus 1 equals whatever this angle is. Well, while I was drawing the reference angles, I happened to see that r related to f. But f is a 90-degree angle. So that makes things pretty easy, actually. 13y minus 1 equals 90. So 13y equals 91. 91 divided by 13 equals y equals 7. Yeah, we're just going right through them now. All right. And then finally for z, I don't have a reference angle for any of these actually. I do know that, oh, here we go. So P is congruent to C, and so that means that C has to be 28. So F is 90. So what that means is 6Z minus 4 has to equal 180 minus 90 minus 28. So let's see, 180 minus 90 minus 28. So this means that has to equal 62. 6Z equals 66. Z must therefore equal 11. So there we go. Again, if you set up the reference angles first, if you set up the reference angles first and correctly, like maybe the most complex thing you'll have to do is something like this, where you have to feed x back in order to find a missing angle, but that really wasn't that complex. Generally, it'll be stuff like this, where if you set it up correctly, you just plug it in and you'll get a whole integer answer immediately. All right, so ABC is congruent to DEF. Ooh. So with this one, A, B, C, D, E, F. There we go. Not to scale, but we have that. It's like just by virtue of how I drew them, all the reference angles are in the right place. All the reference sides are in the right place. There's no mystery. We don't have to worry about reference angles or anything. A is where D is, B is where E is, C is where F is. We're in great shape. AB is equal to 8. There we go. BC equals 19. Alrighty. AC is 14. Great shape. EF is 4x minus 1. Alrighty. And DE is y minus 6. And then I have to find the values of x and y. Oh, well, all right then. Starting with x, because I drew them correctly, and I drew them the same way, I drew them as similar as possible. I just have to go with 4x minus 1 equals 19. 4x equals 20. X equals 5. And there we go. Now for the next one, I have to solve for y. So y minus 6 equals 8, y equals 14. So there we go. Yeah. So in this case, we didn't have drawings that we had. In this case, we didn't have drawings that we had to use, that we had to plot out the reference angles. In this case, I just drew them so that the reference angles were all in the right place. And so when I started putting values on the different sides, I could just say, oh, well, the left side maps to the left side, the bottom maps to the bottom, the right side maps to the right side. And so that's that's the best way to draw congruent triangles, so that makes the problems easier. That is kind of what math is all about. I mean, there is the idea that math is all about making things more difficult or more challenging. That's not really the case. It's about making things really, really, really easy. Alrighty. So for the next one, I've got a triangle ZMK congruent to triangle APY. All right. Looks like I've got a bunch of angles here, but that's no big deal. I've got triangle ZMK, and then I've got triangle APY. All right. M is 112. Y is 41. Then K is 13x minus 37. And then A is 2y plus 7. All righty. Find the values of x and y. Okay. All right. So this is going to be one of those where I'm going to have to solve. I have to solve for x first, because as soon as I solve for x first, then I can use that information to solve for y. So what do I know? I know that 13x minus 37 equals 41, because that's how the congruent statement maps my triangles. So that I'll set that up. 13x minus 37 equals 41. That means 13x equals, alrighty, 41 plus 37 equals 78. Probably going to be 6. Divided by 13, yep, x equals 6. Alrighty, so I've solved for x equals 6. So what that means is, so I know this one's 41. I technically knew this one was 41. So what I'm going to do is I'm going to solve for angle Z. I know that this one is 112, this one is 41. So I guess I could have solved for Y first anyway. Anyway, so 180 minus 112 minus 41. So I know that this angle here is going to equal 27. So that means I can set up the equality 2y plus 7 equals 27. So again, because these triangles are congruent, this angle y is 41. And so that means that angle k is 41. If this is 41 and this is 112, I can subtract both of these from 180, and then that gave me 27. If this is 27, that means that this is equal to 27. So I just set 2y plus 7 equal to 27. Now I solve for y. So 2y equals 20, y equals 10. So I guess I could have solved for y first, now that I think about it. Well, I was planning on solving for x first and then plugging that in for the value, and then I realized, oh, I can just map it over it. Anyway, no big deal. We got it worked out. So if triangle BTS is congruent to triangle GHD, we got all those different sides, so let's just go ahead and start with our drawing first. I'm going to make it a little bit bigger than I did last time so I can work with a bit more space. BTS is equal to triangle GHD. There we go. Side BS is equal to 25. TS is equal to 14. BT is equal to 31. Alrighty. GD is 4x minus 11. Measure of S is 56. That's right. All right. Measure of B is 21. And the measure of H is 7y plus 5. All right. Find the values of x and y. All right. Well, first thing I'm going to do, just to shake things up a bit, I'm going to solve for y first, because, living on the edge. So the way I'm going to solve for y is I'm going to calculate what this angle is first. The way that I calculate this angle is I know these two angles, I'm just going to subtract them from 180, and whatever that number is what this angle is equal to. So minus 21 minus 56, oops, 180 minus 21 minus 56 equals 103. So this is 103. So what that means is if this is 103, then that means that 7y plus 5 is also going to equal 103. So 7y plus 5 equals 103. I'm going to subtract 5 from both sides. So that gives me 7y equals 98. Yeah, it does. So 98 divided by 7. So y is going to equal 14. I've got a whole integer. It only took me 2 steps to solve for it, so I'm pretty sure that's the right answer. So now I got to solve for x. Since I drew my triangles correctly in regard to the congruent statement, I see that I just have to map side GD to side BS and set those equal to each other. So 4x minus 11 equals 25. So 4x minus 11 equals 25. So 4x equals 36. X equals 9. And there we go. That is how you solve for x and y. And so again, when we're working with congruencies and we're working with congruent triangles and working with congruent parts of congruent triangles, step one, a key feature of step one with congruent triangles to make basically any problem into easy mode. Draw a picture, map your reference angles, and it will make everything basically a two-step algebra problem. So yeah, that is the best advice I can give. That is the best advice I can offer.